Hello everyone, welcome to Coders Camp. We are at 6th day of June LeetCode challenge and the problem we are going to cover in this video is longest consecutive sequence. The input given here is an integer array and we have to return the longest consecutive sequence from this array as our output. But here they have asked us to write an algorithm that runs in big O of n time. So let's understand this problem with an example. So here is a given example array and we have to find the longest consecutive sequence. So consecutive is nothing but the next numbers to each other. So here if you start with 1, we have the next integer which is 2 and again next integer to 2 is 3 and again next integer to 3 is 4. So that is going to be of length 4, so that is going to be our output. So it is a pretty simple straightforward problem where everyone would have approached it using sorting. That is, once we sort the array and check whether the next adjacent value is plus one of the previous value. So in that case we will be keeping track of a count or result any variable and increment the count every time we find the adjacent element is plus one to the current element. But for doing sorting, it is going to take big O of n log n time, and our problem statement itself asked us to solve this in big O of n time. So let's see how we're going to solve this in linear time. So to perform this in linear time, we are going to consider the element to be present in a longest sequence if it is not already part of a longest sequence. So to understand that, we are going to iterate the given array and consider each element, and we are going to check if that element is part of any sequence before. If not, we are going to consider that as a start of a new sequence. So let's start from 10. We are going to check whether 9 is there in the array. If you check 9 is there in the array, it is not there. So 10 can be starting off a new longest sequence. So let's add 10 here. So once we find the longest sequence starting, we know the sequence is going to be the next consecutive elements. So we are checking whether 11 is available in the array. Yes, 11 is available. So we are going to add 11 to that list and we are going to check whether the next element to 11 is available. Yes, 12 is available. So we are going to add 12 and again we are going to check whether the next element to 12 is available. Yes, 13 is also available. So we are going to add 13 to the list. Now we are going to check whether 14 is available. No, 14 is not available. So here this sequence ends and this is of length 4. So we are not going to basically add the elements to any list. Instead, we are going to just calculate its length because that is what we needed. So now this sequence starting with 10 ends. So we are going to check 100. That is the next element in the array. So we are going to check whether 99 is present in the array or not. I'm going to tell you why we are going to check the previous element once we complete few iterations. So right now, just have a look that we are going to check whether 99 is present or not. No, it is not present. So this can be a sequence starting. So we are going to start our sequence with 100. We are going to check whether 101 is there. No, it is not there. So it cannot be a sequence. So it is of length 1. So far the maximum length is 4. We are sticking to that as a result till now. So going to our next element, which is 11. So we are going to check whether 11 minus 1 is present in the array or not. Yes, 10 is already present, which actually means 11 is part of a sequence already. Because we have added 11 to the sequence of 10. So whichever sequence started with 10 will be including 11 as well. So we are not going to consider 11 at all because it was already part of a longest sequence. So moving on to the next element, which is 12. We are checking whether 12 minus 1 is there or not. Yes, 12 minus 1, 11 is there, which means 12 must also be a part of another longer subsequence. Even if 10 is not there and we are checking whether 11 is present for 12, yes, 11 is present. So in that case, 12 must be part of a sequence that starts with 11. So anyway, 12 is going to be part of a sequence already. So we are not going to consider 12 as well. So moving on to 4. So we are checking whether 3 is available. Yes, 3 is available. So 4 can be a part of, we already did not come across 3, but 4 is going to be part of a sequence which is going to be starting with 3. So let's move on to 13. 13 minus 1, 12 is also there. So 13 must be a part of or going to be a part of any sequence. So we are ignoring 13 as well. So you can see we have skipped so many elements here in the iteration. So next comes 200. We are checking whether 200 minus 1 is there. No, it is not there. So 200 can be start of a sequence. So we are going to add 200. So checking whether sequence of 200 is present. 201 is not present, so this is also of length 1. So next, moving on to 1. So we are checking whether 1 minus 1 is present. 0 is not present. So we are going to start our new sequence starting with 1. So now we have started our sequence. We are checking whether the next element is present in the array or not. So 2 is present. Yes, we are adding 2. Next, the next element to 2 is also present. 3. So the next element to 3 is also present. 4. So next element is 4 is to 4 is 5. We are checking in the array, but it is not there. So here our sequence ends, and this is also of length 4. So this is another longest sequence we have found so far. So here comes 3 in our iteration. We are checking whether 3 minus 1 is present in the array or not. Yes, 2 is present, which means 3 must be part of some sequence already. Again, same applies to 2. 2 minus 1, 1 is also present. So it must be part of the sequence already. So we are ignoring these elements also. So right now we have the longest consecutive sequence length as 4 updated to a variable result, and we are going to return that as a result. So yes, hope you're understanding this logic. So every time we are counting the sequence, we are checking whether the previous element and the next element to it is present in the array or not. So if we are iterating the array every time, it is not going to work in big O of n time. So for easier access, or in accessing it in big O of one time, we are going to get the help of hash set. So in our hash set, initially we are going to add all our elements from the array to the set, so that we can easily check in big O of one time, that is whether the previous element or the next elements are present or not. So hope I made it clear. As we are going to iterate the array once to check the sequence, it is going to work in big O of n time as expected. So let's go to the code now. So yes, I have declared a set to store all our values. So I'm going to iterate my given array and add all elements to my set. So once I added, I'm again going to iterate my given array to find the sequences. So let me declare a result variable, which is going to start as 0, and finally we are going to return that as a result. So in my loop, I'm going to check if we already have the number minus 1 or not, because we need to find whether it was already a part of a sequence. So if it is not present, in that case we can tell that it can be a start of a sequence. So we are going to initialize a variable count, which is going to count the length of our sequence, and I'm going to check whether the next consecutive elements are present in the set or not. So I'm going to check whether set.contains n++, which is nothing but every other next element. So if it is present, as many numbers, we are going to increment the count. So once we incremented the count, we have the length of that sequence. We are going to update our result, which is going to be the maximum length so far. So yes, that's it. Once we iterated the complete array, our result variable will be having the longest length. So let's run and try. So yes, let's submit. So yes, our solution is accepted. Hope I made this concept clear. Thanks for watching the video. If you like the video, hit like, subscribe, and let me know in comments. Thank you.